All right, welcome back. So just picking up where we left off and finishing off this little introduction to k-nearest neighbors, um, we can start to look at what this would look like if we had more than one predictor. And so now we're supposing that we want to predict type based off of speed and defense stats. And so this example, we obviously just have these two predictors. If you try to visualize this with three predictors, it's still possible. You just need to make a three-dimensional plot. But anything more than three predictors is really, really hard to actually visualize what's happening with k-nearest neighbors from all those extra dimensions. And so for k equals 1, again, the concept is pretty intuitive. We're just looking at what the one closest nearest neighbor is to Dialga, again marked with this red X, and we see that that one close nearest neighbor is this plus sign, so Steele. If we increase k to be 3 and now look at the three nearest neighbors, it gets much harder to kind of see which of these next 2 points are the closest. One reason it's hard is because the scales for speed and defense, although they're like kind of similar, they are still a little bit different. And so for this, I'll just put a question mark. And we'll spend the last part of this handout kind of diving into this issue of scaling our predictors. And so in the following example, we're going to kind of see why we would want to scale any quantitative predictors. And we're going to suppose that we just have two observations in our data set, a dark type Pokemon and a fire type Pokemon. And they're plotted on the following page on this scatter plot. If we were to make a prediction for this black X using k equals 1, and if we were just looking at the plot, I think we would kind of think that our prediction would be this dark type Pokemon up here. So it kind of looks like it's closer than to the green triangle or blue triangle, which is the fire type Pokemon. And so let's see, so we would classify that Pokemon as dark, but notice that the units of weight and height are super, super different. So weight is in the hundreds, while his height is just in the tens. This is going to actually create a problem when we calculate the distance between this black X and this blue triangle, and between this black X and that red circle. And so let's go ahead and do that just to see how it turns out. And so it looks like this triangle is about at a 9 for height and about 250 for weight. Our X looks like it's at 15,350, and our circle looks like it's about 15, maybe 510. And so I'm going to label this D1 and label the second distance D2. And so you might remember from some, I guess, high school math class how to calculate these distances. And so you would subtract your two x coordinates, square them, and then subtract your two y coordinates, square that. And so you would end up, for this first distance, looks like it's 160. And so we're calculating these again because k-nearest neighbors is going to predict the what the shortest. It's going to predict the type as the shortest distance for this X to one of these 2 points. And so D2 calculating distance in the same way. So that's about like 102, I'll just say ish, because I didn't do that exactly. And so we see, because of the different scales of these units, we're actually seeing that D2 is a lot shorter, 102, than the D1 distance, which is 160. So without scaled predictors, we would actually predict this Pokemon to be fire. Which should feel at least a little bit strange, because it clearly is kind of closer to this dark type Pokemon when we look on the graph. What we could do to remedy this issue of completely different scales for our two predictors is just scale all of our predictors. And so you have some experience scaling things before in Stat 113. If you remember kind of using z-scores, that was a type of scaling where you subtract the mean and then divide by the standard deviation. And that's a perfectly valid way to scale quantitative predictors, but I think the most common way to do it for K and N is to scale each quantitative predictor so that it has a minimum of 0 and a maximum of 1. And one way to do that is to take each value of your predictor variable, subtract the minimum, and then divide by the range. And so you'll get some practice kind of seeing this in the .rmd file that goes along with this, but you could take a look to see weight right now is on the hundreds if you just look at the first 3 observations. You could use a mutate statement to create this new variable weight scaled, and then using that formula above, now you see that all the weights are between 0 and 1. If you do the same for height, it kind of makes these variables a little bit more on equal footing. So just the fact that weight was originally on the scale of hundreds and height is originally on the scale of tens, that no longer will have an effect when you're computing these distances for K and N. All right, and so again, the big kind of message here is that before we put any predictors in a K and N function, we usually want to scale them. And we saw the reason why we would want to scale them in this kind of counterintuitive example where we're predicting fire, even though this point is much closer to dark. Okay, so this code you'll kind of encounter in the .rmd. It's just to kind of it's just there for you so you don't have to manually scale all of your predictors in that Spotify example, and you could kind of use it to scale them all at the same time. So for this project, things that we still need to kind of look into. So we still want to look into how to choose K. So we've talked about K equals 1 versus K equals 3, but K could be bigger than that, it could be 10, it could be 7. So how would you choose K? And related to that, how are you going to choose which predictors go in your model? And so Spotify, that data set has a lot of different predictors. So it's got like a song's time, it's got how loud it is, it's got how live it sounds, so all that kind of stuff. So how are you going to choose which predictors go in your model to predict the artist? Related to both of those is how to evaluate your model. And so if you're predicting for a quantitative response, that was kind of covered in Stat 213, there were certain metrics that we looked at. So what metrics are we going to use now that our response is categorical and now that it has more than 2 categories? So we'll kind of look into that as well. Okay, and so this should have just been kind of a quick introduction to a possibility for your final project. As always, definitely let me know if you have any questions, and Like I mentioned before, you're not expected to work on this final project at all over the break, and so you can um, kind of just take your time and go ahead and maybe think of what you would like to do for the final project, and then really start fresh once we get back from Thanksgiving.